Yeah, it's now started. Right, so we need a RMS block to measure my three-phase AC voltage sources, right? So just we need to change the initial parameters into 50 gauge and initial RMS value should be 0. And actually, I'm just going to change my display format in my display function block. It should be long, right? So apply, okay. Now, this is what my thing, right? So now we are just going to use this block to measure my phase-to-phase voltage, right? So phase-to-phase voltage. Just 1 second, just run it 1 second. I'm just going to change the display name, sending and voltage, right? So sending, parallel work பண்ணிட்டே வாங்க, sending and voltage, right? Just run it 1 second. We'll verify that whether we're just having about three-phase voltage, right? So you could see, so phase to phase voltage, right? So in R phase it will be 63 kV and Y phase also 63 kV and B phase also 63 kV. So now just cumulative power, right? So square root 3 into V, right? These are V. So square root 3 into VL is now it denotes that your three phase power supply. So phase to phase pathina 63 kV. So total moon that's called three lines three lines R Y B, R phase Y phase B phase. So across this across R to Y is 63 kV, R to B is 63 kV. So phase to R to B 63 kV. Totally cumulative pathina will have 110 kV, right? So நீங்க கேட்கலாம், so 110 kV நீங்க send பண்றீங்க, right? You have 110 kV over here, but RMS ல measure பண்றப்ப it will show about 63 kV தான். So எப்படி verify பண்றதுன்னா, this each and every to phase voltage will be 63. Then cumulative power பாத்தீங்கன்னா it should be square root 3, right? So square root 3 into VL, that's called line voltage, we need to measure it up. So small calculation we're just going to do it here. You could able to verify that, right? 110 kV எப்படி வந்து check பண்ணலாம். So we need a product, right? So we need a product. So square root 3 multiple பண்ணா தெரிஞ்சிரும் இல்லையா? So I'm just going to use it 1 voltage over here. We are having about 3 phase voltage over here. So I need only one phase voltage மட்டும் எனக்கு வேணும். So we are having about 3 phase voltage over here because 3 phase power source. Now I need to verify that whether I'm just getting 110 kV அப்படின்னு check பண்றதுக்கு I need a line voltage, right? So we are having a phase to phase voltage over here. So for split up over here, we are having about three values are coming here from this line V, A, B, C. We have three values are coming over here. We need to split this value, right? For that purpose, we need a demultiplexer, right? So three values are there. Individual definitely we need a demultiplexer, right? Just search for a dmux, right? So just use a dmux, and now we are just going to connect this dmux over here. Right, so three values on the trigger. In the three values, we actually are just having about three values. Number of output ports will be 3 ports, R, Y, B. Right, I'm just going to use only R value, right? So now I'm just going to use R phase value alone. I'm just using R phase, and it should be multiplied with my 1.732. That is square root 3. So line voltage into square root 3. It will give you about a total value about my kV, right? So we need to use a constant. Constant of the value is reinitialize 1.732. That is equivalent to square root 3, right? So square root 3 into VL, that is called VL voltage, right? So R phase மட்டும் வந்துட்டு இருக்கு, right? Just have a display over here. Just verify that. Now we could see display long value, apply. Okay, this is what my uh, voltage, total voltage, right? Total voltage or total voltage equal to square root 3, where actually square root 3 in my keyboard there is no that square 3, square root of 3 into E suffix L, line voltage, right? Right, just 1 second run it. We'll definitely will get about 110 kV around, right? Because we just multiplied with my line voltage with respect to my display. You could also verify that. You could have that verify also, right? So we'll have one more display whether you're just having a VL voltage, right? So that is called R phase voltage. You could also verify that. right? Anyway, I'm just going to extract it over here from this value. This is what my V, so voltage across my R phase. Voltage across R phase. You could also verify with that it is what my voltage across my B phase, voltage across my B phase, right? So R is what my R of R phase output, Y phase output, and it's a, that is called their B phase output. And it's only extracting voltage across my R phase. Just 1 second, run it. It should be 63 kV. It will coming, right? So it will be 63 kV. I'm just going to use a long value, right? Now you could verify that. So this is what my R phase. So total of 3 values on the trick R, Y, B. Now I'm just extracting with the help of demultiplexer, and R phase would value 63.77 தனியா வந்திருக்கு verify பண்ணிக்கோங்க. And you could also verify that B phase and Z phase. And I'm just going to multiply it with my line voltage, and it is called now we'll have about 110.42. That is what my 110 kV. You could verify that 110 kV is now coming, right? So this is what my sending end voltage, right? So this is how actually we're just calculating sending end voltage. The same way you could able to calculate sending end current. So for that purpose we need one more RMS, right? So for about calculating my sending end current, we need one more RMS, we need one more display, sending end current calculation. So this is what display, just rename it, right? Sending end current. Just side by side work பண்ணிட்டே வாங்க. Sending end current, just change it into long value and click apply. Okay, so this is way about calculating my sending end current. Just 1 second, run it. So sending in current will be 47 ampere. Why actually 47 ampere? Due to my resistive load, already we are having about resistive load about 110 kV, 50 hertz power supply, 10,000 watts. So 10 to the 10 into 10 to the power 3. So 10,000 watts actually we are just consuming as a real active power in my receiving end. So due to this, and right, my generating current, it will be around 47 ampere on per phase. Totally it will be around 150 ampere it will be coming, right? And this is what my sending end. So if you just need to having about sending in voltage, we are having about sending in current. So we need to calculate real power and reactive power on my sending end side. So what actually we need to do, right? So we'll have that one more additional measurement will be there. So for calculating sending in real power calculation, it will be very easy. Real power எப்படி calculate பண்ணும்? V into I into cos pi, right? So because actually we are having AC three-phase power, if it is a DC power in the sense, we are just going to multiply voltage and into current. That's all. But actually in AC power, we need to multiply voltage into current into cos pi, right? We are actually having a voltage over here, right? So we're actually having a voltage and we're actually having a current. Just என்ன பண்ண போறோம், இங்கேயும் demultiplier யூஸ் பண்ணலாம், இங்கேயும் demultiplier யூஸ் பண்ணலாம், and ஒரு line மட்டும் எடுத்துட்டு we're just going to have V into I. Just we will have that real power calculation over here. So it will be very easy, but there is a one more inbuilt function will be there, right? So no need to calculate manually. We're just going to directly jump into use that particular function block, which is already available in Matlab itself, right? So it will be pre-inbuilt function will be available. Where actually we need to go? So we need to go Simscape and use electrical. And then specialized power system will be there. Double click it, and we'll have that fundamental blocks. Just double click it, and we'll have that measurement blocks will be there. So in that it will be measurement will be there. So in that there is one more additional measurement available function will be there. That's called additional measurement. Just double click it, where you could see additional measurements, right? So we are going to have a digital flicker meter, Fourier transform, and we'll have a mean calculation, and we'll have a PMU about we'll have a sequence measurement, and we'll have that one more thing over here, right? So power. So this is one more power measurement. It will be going to calculate our real power and reactive power for a single phase power supply. We are actually using a three-phase pi transmission line. That's why we are actually just going to use this one, because we are using three-phase transmission line. That's why we are just going to use this function block. Just double click it, you could able to use it. So other than that, we are having a number of things will be there. Instantaneous power calculation, THT, total harmonic discharge, we could able to calculate. Which a number of things will be available over here. Now actually we are just going to use this block to measure about my instantaneous three-phase power as well as P, real power as well as reactive power. Just double click on it and add to model block. Now this function block is now coming over here, right? This function block is now is using to calculate my real power and reactive power. I'm just going to use it over here. So concept மட்டும் பாருங்க ரொம்ப ஈஸியா தான் இருக்கும். So right now we need to connect VABC terminal, IABC terminal because real power and reactive power calculation, right? So I'm just going to connect it real power after RMS, right? So after RMS I, so here it will be I will be there, right? So already we have two RMS over here. That's why I'm just going to get this RMS point over here. So VRMS, IRMS. So now we are just going to display those things. So use display, right? Real power, sending and real power, right? So sending and real power, sending and real power, and sending and reactive power, right? So two more displays is needed, right? So long, let's long, and one more display, sending and reactive power, Q, right? So Q is now been reactive power, right? So reactive power, real power, simply just long, just use long. Just 1 second, just run it your program. It will all automatically calculate your sending and real power and reactive power. Just see. This is what my real power. This is what my reactive power. Right. So this is what our real power and reactive power at my sending. Right. So now just repeat this same procedure. Right. So in my receiving side, just I'm just going to give you about 5 minutes. Right. So 5 to 10 minutes. So just do this same procedure on my receiving end side, right? So just use my and receiving side, just calculate receiving end power and receiving end voltage and receiving end current. Just calculate everything. Just make it fast, as well as calculate this one also, right? So you can calculate in my receiving end side. If anyone just having doubt in this, just unmute your mic and just give me. Meanwhile, I'm also doing, right? So parallel just doing in my receiving end side. Or maybe just simply copy and paste, nothing wrong in that. Simply copy and paste, it will work. Definitely it will work, right? It's nothing uh, difficult, it will work. I'm just going to use it entire copy. I'm just going to paste it. So it will work definitely, no issue. But we need to rename this entire blocks, right? So definitely we need to rename it. Little bit, I'm just going to move it over here. Now we need to connect RMS, right? So receiving end current, we need to rename it, right? Receiving end current, receiving end voltage, receiving end current, receiving end reactive power, receiving and reactive power, voltage at across phase. This all will be same, no issue. Receiving end power, receiving end power, right? So remaining it will be same. Just connect this terminal alone. So now we're just going to use receiving in voltage. That's why VABC and IABC. Right? Just 1 second, just run it. Just verify that எல்லாமே longல இருக்கான்னு check பண்ணிக்கோங்க. Long numerical display data format. Right? Now we're just going to run it 1 second. Now this is what my receiving end power and receiving end reactive power, and as well as my receiving end voltage, it will be now receiving end voltage. It will be around 110.111, right? So 1.111. This one about 110.424, because actually we are having about uh, load will be there, three phase real active power load will be there. If actually I'm just going to remove this active power in the sense, right? So I'm just going to use it a zero voltage, right? 0 watts in the sense there is no load is now connected. In such a case, that definitely my receiving end side voltage will be much high because of my due to my Ferranti effect, right? Anyway, I'm just going to remove this reactive power also, right? So these are things already we have seen, right? So if there is no load on my receiving end and there is no reactive power compensation, definitely my receiving end voltages will be somewhat very high. So due to my Ferranti effect, now we will see there is no load, there is no reactive power compensation will be over here on my load side. Just verify that once again, due to my Ferranti effect, definitely my sending in voltage will be somewhat very high. We are actually sending about 110.4 kV. We'll see now. Already we have simulated over here, right? Now there is small edge. There is a error will be there. We need to remove this block. Then only we will get it right. So we're just going to remove it. This RLC block. Right. Now we're just going to run it once again. You could see. I'm just going to zoom it once again. Right, so my sending end voltage 110.9 kV sending in, my receiving end side about 117.2 kV. So got an idea, right? So due to my Ferranti effect, right? So due to my Ferranti effect, the receiving end voltage is somewhat very high compared to my sending end. So 110, 117. So due to my Ferranti effect, how we could able to remove this Ferranti effect, right? So it will be very easy. Already we have seen, so we need to use a reactive power compensation over here, right? So we need to add a reactive power over here. So already we have seen that, right? So this one, three phase reactive power, three phase RLC load. We need to use it. Three phase, three phase parallel RLC load. We are actually going to use only reactive power, that is 110 kV, 110 kV, 50 Hz power supply. Active power should be 0. Reactive power will be 10 to the power e power 6. Actually, very randomly I'm just choosing. And capacity reactive power should be 0. This is one reactive, three-phase reactive power. Three-phase parallel reactive for common right? By using this, definitely you could able to, I'm just going to rotate it 1 second in such a way that you could able to easily connect it, right? Right, I just connected my three-phase compensation load over here, right? Now you could verify that my Ferranti effect is going to be getting removing. Now you could see I'm just going to remove this current value over here, right? Now you could see your current effect rates, it will going to be getting eliminated, right? So because I just added a reactive power compensation over here, right? Just 1 second, just run it 1 second. We are actually sending about 110 kV. Now due to this reactive power compensation, we actually removed about 7 kV. Now we'll have about the same voltage actually we are just receiving from a receiving side also. By adding reactive power compensation, you could able to remove Ferranti effect, right? So these are the things we have seen in a previous class. Anyway, we'll have active load also, we're just going to use it over here. So we're actually not having any real power consumption over here, right? So only we are actually injecting reactive power to this my network, right? That's why it's now going to be canceling that voltage. And now we are not actually consuming what could I say, my real power actually over here, right? Now actually we're just going to connect my real load. Actually we're just going to use one more load. I'm just going to use a RLC combination 110 kV, for example 10 e to the power 3, and This one I'm going to use my real power actually here. Actually, I'm just going to use a real load, three-phase parallel real power, right? So real power, real load, right? So real resistive load, resistive load. For example, right? I'm just going to connect resistive load over here. So R to R, B to B, C to C. 10,000 watts I'm just consuming. But for example, uh, yes, 10,000 is more than enough. Right? I'm just going to run it once again. Yeah, right. Now load is also connected, reactive power also connected. Now it's time to calculate voltage regulation as well as my transmission line power efficiency, right? So what is the formula for calculating voltage regulation? So voltage regulation formula, it will be very easy, right? So sending in voltage minus receiving in voltage divided by sending in voltage into 100 IVs, right? So anyway, I'm just going to show you that one more thing. This formula for voltage regulation: sending in voltage minus receiving in divided by sending in into 100, right? So now we are having about sending in voltage, receiving in voltage, everything actually we are having, right? So everything we are having. Now we need to calculate. So sending in minus receiving in divided by sending in, right? So this is what my formula for voltage regulation, percentage voltage regulation, right? So we're actually having sending in voltage over here, right? So already we are actually having about sending in voltage in our phase. We are having over here, right? And we're just going to use a simple formula, right? So we need a subtractor. So we need a subtractor, right? So sending in voltage over here, right? So this is what my sending in voltage, right? So we're actually just going to calculate RMS value. Just use RMS value, right? So subtract RMS value, and we are just going to use my sending in minus receiving in. Where actually my receiving in over here? This is what my receiving in. Just connect it over here. So this is what my receiving in, right? So divided by sending in, divided by sending in minus receiving in, divided by sending in. So we need to divide, divider, right? So divide by sending in voltage. Already we are having about sending in voltage over here, right? So now sending in, right? Into 100, right? That's a formula. Constant actually, or a gain, no issue. We could use a gain also. So gain or initial value should be 100, right? So it would be 100. No, 100. So this is a simple formula, right? So now we need a display. So this will give you about three lines, right? So R, Y, B, three lines order efficiency comico. If you just need a single phase, right? So single one to another, we need to use this alone, right? So after demultiplexer, just go with it. This will give you about percentage voltage regulation at my three phases, right? So percentage voltage regulation. Simple formula என்னது அது அப்படியே நான் Simulink மாத்திருக்கேன். That's all. Percentage voltage regulation. என்ன பண்ணணும்? Sending in minus receiving in divided by sending in into 100. That's all, right? I'm just going to run it once again. You will have that three phase, right? So we'll have about three phase. That's why about this much is coming, right? So we need a single phase in the sense, right? So just remove this block and connect it after my sending. The same way in my receiving end. Just connect this block after my this thing, right? Just once again, just run it and divided by this one, my sending in, right? Where actually my sending in over here. These are my sending in. Just once again run it. We'll have the deficiency about this much, right? So by single ஒரே ஒரு line மட்டும் எடுத்திருக்கேன். About my voltage regulation around it will be 0.28 voltage regulation, 28%, right? So it will be very low regulation, right? Just use this simple calculation where it could able to calculate my this one. So instead of gain, it could able to use a constant also, no issue. Both are same. Could also use constant. Constant is we need definitely we need one more multiplier, right? So when product we need it. So product. So product. So this is what my sending in, and actually we're just going to connect this block about 100. We need to multiply with 100, right? Then only we could able to calculate 100%, right? 100 and connect this display, right? Just 1 second, just run it. About the same value it will become, right? No issue. So this is what my voltage regulation, right? About my this particular network, right? And final one, that is my transmission line power efficiency, right? So power transmission efficiency. So what is the formula for calculating that one? So we'll have that simple formula. Real power, that is receiving power divided by sending power, right? So this is what output, this is what my input. என்னோட நெட்வொர்க்ல பாத்தீங்கன்னா பவர் எஃபிஷியன்சி என்னது அவுட்புட் பை இன்புட், ரைட்? ஸோ எஃபிஷியன்சி ஆல்வேஸ் சிஸ்டமோட அவுட்புட் divided by systemoட input into 100, right? That's what my efficiency. So this is what my real power divided by real, that is called real power at my receiving end divided by real power at my sending end into 100, right? So already we have calculated about real power, right? So receiving end voltage, and where actually we just calculate real power over here, right? So this is what my real power at my receiving end. This is what a real power at my sending end, right? So this is a simple formula, output by input. So power delivered at receiving end divided by power sent from sending end into 100. This will give you about transmission line power efficiency, right? Simple calculation will be over here. We need to take it P from here, and we need to take it from P here, and we need to make a divide, and we need to make a multiplication. That's why I'm just going to use a divided function over here, right? This is what my power delivered at my sending end, sorry, receiving end, right? So divided by sending end. Simply I'm just using a dragging, right? So power at my receiving end divided by at sending end. We need a multiplier, 1 second, into 100, right? So this one into 100. This will give you about my efficiency, transmission line efficiency. We need one more display. This is what my transmission line efficiency, right? Just 1 second, just run it. So it will be around 110 efficiency. Why it should be 110 efficiency? It should be less than 100, yeah, it should be less than 100. But why actually it's now showing about 110 line efficiency? Because my sending in real power it will be this much, my receiving in real power it will be somewhat very high. Because the real power at receiving end power அதிகமா இருக்கு. That's why my calculation is now showing like this. For that purpose, actually, we are injecting reactive power over here, right? So that's why this is a more issue. I'm just going to remove this reactive power alone, because actually we manually murdered, right? So that's why reactive power injection it will be somewhat very high here. That's why. So now we need to use a little high because of my current effect. It will be somewhat very, it will be somewhat very, now it should be somewhat correct, right? Actually I just choose the randomly trial and error method. I just choose to inductive reactive power. It will automatically based upon my value. Actually I just fit it over here. It will inject a reactive power to this network. That's why my receiving end power is also going to be getting changed. Now I just increased my this one, right? So about my reactive power in such a way that I could able to remove my front effect in such a way that you're just going to have a somewhat real values, right, over here. If it is a real transmission line parameters, we are just choose this well map, that's called design mantra. We are having about real transmission line values irundhuchuna no issue, it will be perfect our curve, because actually we are just choosing about assume la edutho trial and la edutho. That's why it will be somewhat changing. Now it will be, now it will be okay, because actually I just increasing my reactive power. So in such a way that you are just going to remove my current effect. Now my transmission line efficiency is about 86%, right? My real power which is at my receiving end, it will be 41 4 10 to the power is 6, as well as my 48 it will be my sending and real power. Now my efficiency will be around 86. My voltage regulation about 34 percentage, right? So it will also it's going to be changing, right? So due to my reactive power, right? So that's why we need to choose a perfect value, right? So for that purpose we need a real values for an entire network systems, right? So these are the third experimental first half, right? So just save it 1 second. இதை நீங்க அப்படியே ஃபைல்ல சேவ் பண்ற மாதிரி இருக்கும். In our at the end of the entire lab, you need to be a submit, right? So then only you will get a full mark, right? Just save பண்ணிக்கோங்க. I'm just going to give you about 5 to 10 minutes over here, and let we start about second half. It's going to start, right? So cars serial, right, will start by around 11 o'clock, right? So once it's finished now, we'll jump into that second part of our third experiment, right? Anyway, I'm just going to give you about 5 to 10 minutes over here. Just finish it up this one, transmission line model parameters calculation, right? Any doubt up to this rail and power calculation, these things, and efficiency calculation, voltage regulation calculation. Anyway, we'll have one more thing we could able to calculate, apparent power actually. So receiving end apparent power, sending end apparent power, you could able to calculate. These are the things it will be called real power. Actually, we are just having, right? So apparent power we need to calculate. So apparent power it will be always it will be a little bit higher than that of my real power, because my apparent power it is now is equal to kVA. Actually, it will be including about reactive power, right? So reactive power and network add add. Then only the apparent power is now in the form of kVA. Definitely it will be little bit higher than that of my real power. We'll see how we could able to calculate apparent power, right? So definitely we could able to calculate apparent power. It will be very easy, right? So we need a V into I, right? So and we need to add it over here. Definitely we need a multiplier. That's called, I'm just going to use it multiplier over here, right? So I'm just going to copy this function over here. Simply I'm just going to use this function block multiplier. That is called my sending end voltage into sending end current, and then we need to add it over here, right? So definitely we need to add it, sending in voltage and sending in current, and we need to add it, right? So that's why we need a math operator. We need to some wise element we need to add it, right? So then only we could able to calculate sending in power. That is called apparent power. So math operations, we need a sum of elements, right? So sum of elements add to block. So it's now coming, it's sum of elements. So this one, and we need to have a display. This is what my apparent sending and apparent power. Sending and apparent power. Apparent power will be in the form of S equal to, right? So capital S equal to 3VI, right? So 3 in the sense 3 phase, and V into I. So 3V, 3I, right? So then only it will be coming, right? So it will be in the form of long. Just 1 second, just run it. This is what my sending and apparent power. It will be little bit higher than that of, it should be little bit higher than that of my real power, right? So where actually we are just having real power actually 48, where actually we are having about 41. In my sending it will be 48. So it will be little bit higher than that. The same you could able to calculate my receiving end also, right? So up to this about we have finished about entire thing. So இதுக்கு மேல calculate பண்ண முடியும். Power factor வேணா calculate பண்ணலாம், but it's not more than enough. More than enough. Right? So we'll just going to pass it over here. Save பண்ணிக்கோங்க, and we'll directly move into next part, right? Gauss seidel will move. Right? Finish it up. Anyone just confirm me? Finish பண்ணிட்டீங்களா? இல்ல டைம் வேணுமா? பார்க்கறதுக்கு பெரிய சிமுலேஷன் ஃபைல் மாதிரி இருக்கும், பட் கான்செப்ட் அண்டர்ஸ்டுட் பண்ணிட்டீங்கன்னா it will be very easy. So right, so power system easy தான், right? If you need more time, I will give you about 5 minutes, or else we'll continue about second half. Anyone just confirm me? Hari, time வேணுமா? ஓகே ஓகே, புரியுதா? அதாவது புரியலன்னா எனக்கு உடனே பாஸ் பண்ணிடுங்க, நோ இஷ்யூ. நமக்கு நிறைய டைம் இருக்கு, ஸ்லோவா கூட போகலாம். நீங்க கனெக்ட் பண்ணது தெரியல, எங்க சரி எங்க கனெக்ட் பண்ணிட்டு தெரியலன்னு சொன்னா கூட நான் just going to pause it. Or else easy understood ஆகுதா?
Yes, sir.
Okay, okay. Finished, pa? We'll continue.
Yes, sir.
Shall I wait about 2 minutes? நீங்கள் ஸ்லோவாக கூட ஒர்க் பண்ணுங்க, ஒன்றும் பிரச்சனை இல்லை. நமக்கு நான் 1 ஹவரில் முடிச்சிடலாம், ரைட்? காசியில் முடிச்சிடலாம், நோ இஷ்யூ. Shall I start, Hari?
Yes, sir.
ஓகே ஹரி, ஃபினிஷ்ட் தானே? ஏதாவது டவுட் இருக்கா ஹரி? அது என்ன, மற்ற யாரும் மைக்கில் அன்மியூட் பண்ண மாட்டேங்கிறீங்க, ஹரி மட்டும் தான் ஆன்சர் பண்ணுறாங்க.
No, sir.
ஹரி,
இது
ஆன்சர் வந்துருச்சா பார்த்தீங்களா?
ஆமாம் சார்.
ஓகே ஹரி.
17 பாயிண்ட் சம்திங் கிட்டக்க வந்திருக்கு சார்.
ஓகே ஹரி, அப்படி ஷேர் பண்ணுங்களேன், நான் செக் பண்ணிக்க வருவேன்.
ஓகே சார். ஒரே ஒரு செகண்ட்.
அட்லீஸ்ட் நீங்கள் ஒரு தடவை பண்ணீங்களே, ஐ எம் ஹாப்பி அபவுட் தட். நீங்கள் ஷேர் பண்ணீங்களா? ரிமைனிங் மெம்பர்ல இருக்கீங்களா? ஸ்ரீனிவாஸ், லேப்டாப் ரெடி ஆயிடுச்சா ஸ்ரீனிவாஸ்? டார்ஜன்
சார் ஆப் ரெடி ஆயிடுச்சு சார், பட் ஸ்லோவா இருக்கு சார், ரொம்ப
ஸ்லோவா இருக்கா? ஓகே, ரேம் உங்களுக்கு ஸ்லோவா இருக்கு. எனக்கு ரேம் ஸ்லோவா இருந்தா கொஞ்சம் ஸ்லோவா தான் இருக்கும். ஐ திங்க் டார்ஜன் வச்சிருக்கீங்க.
ஒரிஜினல் போடலனால அப்படிதான் வரும் சார். ட்ரையல் வெர்ஷன்
மேபி இருக்கும். நீங்க எனக்கு 12 o'clock மேல கால் பண்ணுங்க, வில் செக் பண்ணிக்கலாம் ஸ்ரீனிவாஸ். டார்ஜன், நீங்க டார்ஜன் ஒர்க் பண்ணீங்களா? டார்ஜன் பாபு, மகேந்திரன், நீங்க?
எஸ் சார்.
ஆன்சர் வந்திருக்கா?
சார் இப்பதான் பண்ணிட்டு இருக்காங்க, அந்த நிறைய ஆப்ஷன் Matlabல.
ஓகேடா, ஓகே ஓகே ஓகே. அண்ட் ஹரி கௌசிக், ஓகே, நீங்க சால்வ் பண்ணிட்டீங்க. கௌதம், கோகுல் ஆர் காயத்ரி, ரவிசங்கர், பவித்ரா எஸ், மனோசரத், லோகேஷ். If anyone just finished, ஹரிஸ் வந்து முடிச்சிட்டாங்க. Remaining anyone just finished, na just share your screen. If you have any doubt, na just share me. We'll just continue, no issue. Okay, ஹரிஸ் நீங்க ஷேர் பண்ணுங்க ஹரி.
ஓகே சார்.
வாவ், பெரிய நெட்வொர்க் இருக்கு ஹரி. எஸ் ஹரி, கரெக்டா தான் இருக்கு, கரெக்டா இருக்கு. ஓகே ஹரி, சூப்பர். பேரலா ஒர்க் பண்ணிட்டே இருந்திருக்கீங்க. ஓகே ஹரி, ஓகே, குட் குட் குட். ஓகே, தேங்க்யூ ஹரி. அண்ட் அட்லீஸ்ட் ஐ எம் ஹாப்பி, ரைட்? ஸோ அட்லீஸ்ட் ஒருத்தர் ஸ்க்ரீன் ஷேர் பண்றீங்கல்ல, வேற யாரும் ஷேர் பண்ண மாட்டேங்கிறீங்க, தட்ஸ் வை, ரைட்? ஸோ ஏன்னா இவ்வளோ நேரம் நம்ம டைம் ஸ்பெண்ட் பண்றோம், ஸோ அதுக்கு அவுட்புட் வரணும் இல்லையா? தட்ஸ் வை. ஸோ ஒரு கிரிக்கெட் விளையாட போறீங்க, அட்லீஸ்ட் வின் பண்ணணும். 10 மேட்ச் 2 or 6 மேட்சாவது வின் பண்ணணும். சும்மா போயிட்டு நேம் சேக்கு விளையாடுறது வேஸ்ட். தட்ஸ் வை நீங்க ஒரு 2 hours இங்க ஸ்பெண்ட் பண்றீங்கன்னா, இந்த 2 hours கொஞ்சமா ஏதாவது லேர்ன் பண்ணிக்கணும் அட்லீஸ்ட், ரைட்? ஸோ வாலண்டியரா வாங்க, ரைட்? ஸோ நான் உங்களை திட்ட போறதும் இல்லை, உங்களை மார்க் குறைக்க போறதும் இல்லை, நத்திங், ரைட்? ஸோ வில் ஹாவ் டிஸ்கஷன், தட்ஸ் அப், ரைட்? ஸோ சம் டெக்னிக்கல் டிஸ்கஷன், அவ்வளோதான், right? And just come forward, right, sweet people, right? Okay, and we're just going to continue. I think I'm just going to share my entire screen once again, right? We'll continue by uh, that second of our third experiment, right? We'll continue. I think I'm just going to share one more screen, right? So I think one more white screen is now shared, right? So Jamboard is now visible to everyone, right? So anyone just confirm me, Jamboard, right?
எஸ் சார்.
Okay, okay. Okay, anyway, so before going to that, I'm just going to share with you some of our example, right? So already we have about our this is what our manual actually. So directing in the manual pathina it will be somewhat difficult, right? So the coding it will be somewhat very easy though, but not that much difficult. It will be very easy. We'll see. So I'm just going to share with you one more third experiment manual. So this is what our Gauss serial model. It will be somewhat it will be a confused one, but no issue. So within or 40 to 50 minutes we will just finish it off, no issue. So the third experiment, second half, it will be load flow solution equation Gauss seidel method, right? So why actually Gauss seidel method is now coming into power system, we'll see one by one. And this was actually one more this is what a coding பார்க்கிறதுக்கு ஒரு different இருக்கும், but it will be very easy, right? So I'm just going to give you about these things, right? No issue. So this is a set of algorithm actually we're just going to follow, and we need to what could I say? We need to uh, form a Y-bus matrix. From the matrix, we actually just going to calculate entire thing, right? Now, actually, these are the sum of a given problem. From this problem alone, we're actually just going to at least over here. So this is what a exact program we're just going to use in our Matlab. We'll see one by one. So it will be around 30 lines. It will be very easy. So direct on the coding உங்ககிட்ட கொடுத்துட்டு நீங்க காப்பி பண்ணி MATLAB look பண்ணீங்கன்னா it will work definitely. But actually, what are the things is now going to happening inside that coding? That was most important thing. It will be here, right? So we'll see what actually it's now happening and what are the things actually we're just going to learn it from here, right? We'll see. Before into that, I'm just going to start a small power system network. With that power system network, we're actually just going to go with it, right? Anyway, now let us just parallel work பண்ணிட்டே வாங்க, right? So from this small problem alone, we're actually just going to go with it. So these are the problem actually I'm just going to get it from the, some of a textbook, right? So Shadi Hardet book, already we have shared that link, right? So we'll have that a number of things will be there and from that book, right? So there was small network we're actually just going to start it, right? Just note it down. So this is what my generator, just parallelly just side by side work பண்ணிட்டே வாங்க, right? This is what my generator. So ideal generator, for example, right? So this has its own generator, and we are actually generating electrical power, and actually we are just going to feed it into bus number 1. Here actually we are having bus number 1. So after that we're actually now connecting with my transmission line, right? Where actually we are having about a transmission line about 100 kilometer or maybe 1000 kilometer based upon my distribution purpose, right? Definitely. Then after that they'll have about one more transmission that's called bus number 2. We are having about 2 bus about a single transmission line, and we'll have one generator, right? So this is what my generator, right? And after that we are having about one load is now happening over here. So this is what my load. So load always they will just use a rectangular shape. Already we people studied in a power system analysis subject, right? And it will be grounded as well as. These are my load. So load is always it will be in the form of rectangle shape. They'll just mention. So with this small example, actually we are just going to, with the help of this small example, we're actually just going to use a Gauss seidel method to solve equations about this entire power system network. Small power system, single generator. So totally bus number 1. So parallel work பண்ணிட்டே வாங்க. So bus number 2, right? And we'll have a transmission line, right? It will have its own resistance, it has its own inductance, right? Just to assume that we are having about that line impedance J 0.1 per unit. Just assume 0.1 per unit. This is what my line impedance, that is called my Z, right? Line impedance, it will be Z imaginary, it will be 0.1 per unit, right? And we need to have a load flow analysis for this simple power network over here, right? And we'll need to do an analysis for this purpose, right? Definitely. Here that generator actually we are just having about ideal generator. Definitely it's going to generate a voltage, right, at magnitude V1 at del angle about del 1, right? This is what voltage actually we are just going to generate over here. And after that actually we are just generating this power into this network, and actually the power is now flowing here, right? The power is now flowing, and we'll have a load over here also. And definitely there is a line impedance, the line resistance is now happening over here. Due to this, my receiving end voltage is going to be somewhat different. So it's not, definitely it will be, actually it's not equal to V1. So we already know kandipa V1 V2 வந்து different தான் இருக்கும். Because of my transmission line, it will be going to be there. And del angle 2. So these are the variables, unknown variables, V1, V2, del 1, del 2. And here actually the current which is now flowing into that network is now I, bus number 1 to 2. That's why I suffix 1 to 2. That is current which is now flowing into this network I1, 2. Right, got the idea? Now we have about two questions, right? We'll have the two assumption over here. We are having about unknown variable, right? So V1, V2, del 1, del 2. For example, what is the question actually we have over here, right? So we'll have a question like this, right? So first question, right? So if anyone just gives the value about V1 del 1 கொடுத்துட்டாங்கன்னா, definitely we could able to calculate V2 del 2. If anyone just give me V2 del 2, definitely we could able to calculate V1 del 1. So in that small thing பார்க்கலாம். And load also they just given, right? So loaded value கொடுத்திருக்காங்க in the form of apparent value. So loaded value, for example, in this given problem, so 0.6 plus j.3, j.3. This is what a load, right? So this is what a load value. This is what this is what load. This is for entire power system network. First question, if V2 is V2 and del 2 is given. So for first question, V2 del 2 is given, that is 1.0 magnitude at 0 degree. Now they are actually asking about V1 del 1. So first thing, they are given first question V2 del 2 கொடுத்துட்டாங்க, this is the value, and they are actually asking about V1 at angle del 1. They are actually asking. We could easily calculate, right, with the help of a simple formula, right? We could able to calculate this entire thing. We'll see. This is a very introduction problem. You people already seen in our previous semester itself, right? I'm just going to use one more page, right? This is what my first page. I'm just going to use my second page, right? And what is a simple formula? So actually they just given that is we actually having z value already we people know what is z value. So j.1, right? So j.1 per unit, and s actually they just given s order value 0.6 j.3. So I'm just going to use it a different color, right? So s order value, what is s order value? 0.6, 0.3. So 0.6 plus 0.3 j. These are the values actually they just given, as well as V2 actually they just given, right? So V2 கொடுத்துட்டாங்க, V2 del 2 கொடுத்துட்டாங்க. So what is the value for V2 at angle del 2? They just given 1.0 magnitude at 0 degree. These are the things actually they just given. But actually they're just asking, they're actually asking about V1 del 1. They're asking V1 del 1. They're just asking. It will be very easy to calculate, right? So எப்படி calculate பண்ணலாம்? Anyone just have an idea? Anyone just have idea, please? So clue will be there. So these are the clues. I'm just going to use the clue. We're actually have split up. So what is a clue? Clue pathina, it will be very easy. So simple power calculation, P equal to V into I. Simple formula, power calculation. Now we'll having about apparent power. That's why S equal to V into I, right? So we could able to calculate I over here, right? So actually we don't know about I12 current, but we are having about V2, right? So I12 and V2, that is a V2 I12, that is my receiving in power, right? So I'm just going to in the form of apparent power. I'm just calculating, that is V2 and I2. So definitely you could able to cut S by V2. So from this we could able to calculate I, right? So actually I v2 actually they just given, right? So v2 actually they just given. Definitely we could able to v2, and definitely we'll have s value. We could able to calculate I12, right? So I12 kadachina, definitely I could able to calculate my v1. So எப்படி calculate பண்ண முடியும்? So at actually I12 கிடைச்சிருச்சுன்னா v1 have v1 is now this side, v2 is this side. So அப்ப என்ன பண்ணலாம்? v2 minus v1 divided by whole impedance. That shows your current, right? Simple formula. What is formula for I equal to simple Ohm's law, v by r. Instead of r actually we are having impedance, right? So v by instead of r actually we are having impedance. So v எப்படி இருக்கு? So we are actually having 2v, that is v1 and v2. That's why v1 minus v2. So totally I12 equal to v1 minus v2, right? And instead of r actually we are having impedance, right? So v1 நமக்கு தெரியாது, we need to calculate v1, but actually we are actually they just given v2 கிடைச்சிருச்சு, and actually we are having I2 in the form of s and v2, right? We are having about those values. Impedance also we are known. Now easily we could able to calculate v1. It's very easy to calculate, right? Simple formula from Ohm's law, right? We could able to calculate. Now just substitute every values over here. Definitely you could able to calculate. So I2 நம்ம எப்படி calculate பண்ணணும்? S by v2. That is a complex conjugate values. Everything is now complex conjugate in nature, right? Everything is now complex conjugate in nature. Final formula, it will be very easiest one. That is I12, right? I'm just going to use a different color. I12 equal to, so v1 minus v2 divided by z. Instead of directly I'm just going to calculate I2. Simple formula I2 எப்படி எழுதிருக்கோம் இப்போ? Just got idea. I2 எப்படி எழுதிருக்கோம்? In the form of apparent power divided by v2 voltage, right? I'm just going to replace this entire I12 in the form of apparent power S complex conjugate divided by v2 complex conjugate, right? So I2 எப்படி replace பண்ணிருக்கேன்? In the form of S by v, and remaining this will be same. So v1 minus v2 divided by z, right? Got idea? Simply actually we're just going to calculate these values. Just substitute every values over here. We'll definitely be able to calculate this entire thing, right? So v1 we don't know, right? So v1 we don't know. So v2 order value 1.0 whole divided by z order value, right? So what is z order value? J.1. Already we know the values. Z j order value 0.1. What is the value for S complex conjugate? What is the value for v2 complex conjugate? Right? So we need to calculate, right? So we are having about S order value. So this is what my S order value, 0.6 plus 0.3j. We need to have a complex conjugate in the sense we need to use minus terminals, right? So we need to use a minus complex conjugate, that is called 0.6 complex conjugate na opposite in nature, right? So 0.6 minus 0.3j. This is what my complex conjugate of my S, right? I'm just going to replace this entire thing. So 0.6 minus 0.3. So 0.6 minus 0.3 into j divided by v2, right? So v2 complex conjugate. So v2 value is now already we know that v2 value 1, right? 1.0. Now just cross multiply and just find out v1 value. Just make it first. Just cross multiply everything. We need to be able to calculate v1. So v1 value சொல்லுங்க. Just cross multiply. So j.1 into whole things and 1.0 into anything is now same thing. Right? What is the value? So j cross multiply பண்ணுங்க. j.1 into this term is now multiplied with this term, and this term is going to be multiplied with this term. So 0.6 minus 0.3j, and this one is now multiplied over here, right? So v1 into minus 1. So minus 1 will be over here. So minus 1 over here. This minus 1 is now coming to this my right side. It will be coming plus 1. Make it fast. What is the final value for V1? Anyone just tell me? Make it fast. Anyone just tell me about V1 value? Simplify பண்ணுங்க அவ்வளவு முடிஞ்சது. So in our room, J 0.1 into 0.6, 0.06 J, right? So minus 1 plus V1 equal to 0.06 J, remaining time 0.06 J. So minus 0.3 into 0.1, 0.03 into J square. J square of value minus 1. So minus 1 into minus 0.03 plus 0.03. 0.03. So we need only V1. That's why V1 equal to this minus 1 plus 1, right? So 0.06 plus 0.03 minus 1 is now become this plus 1. So final value for V1 1.03, right? So 1 plus 0.03 plus 0.06 J. This is a V value, right? So this is what my V1 value. So given problem V2 கொடுத்திருக்காங்க, right? So now in our given problem V2 கொடுத்துட்டாங்க, definitely we could able to calculate V1, right? So V1 calculate பண்ணி it will be very easy. So simply by using Ohm's law we could able to calculate, right? So V1 what value 1.03 plus 0.06. So we need to calculate angle in the sense we need to calculate angle in the sense. Now I'm just going to use it Matlab over here, right? So what is the formula for V1? So now V1 என்ன கண்டுபிடிச்சு வச்சிருக்கோம்? V1 I'm just going to use it over here. So V1 equal to 1.03. That is V1 equal to 1.03 plus what is the value for remaining things? 0.06 J. So if you're just going to enter 0.06 J, in the sense we couldn't able to use directly I over here. So for that purpose we need to use 1I. We need to use 1I. If you're just going to use 1I, in the sense total things is now going to called J. Directly நம்ம I use பண்ண முடியாது. We need to use 1I. Instead of directly using I, we need to use 1I. Now just use it. So V1 க்கு என்ன assume ஆயிருக்கு? Assign ஆயிருக்கு 1.03 plus 0.06 J. Right? We need to calculate angle for this V1, right? For that purpose, we need to calculate angle value. It will be some of a radian இருக்கும். We need to convert it into degree. So normally Matlab is now in the form of a radian. We need to convert into degree. So for that purpose, we need to use that formula. So angle calculation angle of V1. Angle of V1 we need to calculate, but should be in the form of degree. So radian to degree it will be very easy. So 180 divided by pi, right? So 180 divided by pi. 180 divided by pi, that is 3.14, right? Angle of V1 now 0.05 degree, right? Got idea? If you're just having much doubt, you just go with it. 1 second, I'm just going to use it one more bracket. 180 could have the different formulas. 180 divided by angle of V1, right? So 180 divided by 3.14. Angle of V1 into 180 divided by 3.14. So it will be, this is what right answer. Actually now bracket na mathi poruta, right? So it will be somewhat, it will be angle of V1. We need to calculate angle of V1 and should be multiplied by 180 and divided by 3.14. Definitely will have a degree, about 3.33 degree, right? So got the idea how to calculate angles, right? So finally my V1 about 1.03. So V1 1.03 at 3 point, what is the degree value? 3.33 degree. 3.33 degree per unit. This is what actually V1, right? So simple formula and simple things will be there, right? Now we'll have one more thing, right? So actually they just given about V2. Definitely you could able to calculate V1. Suppose in one more case, right? So one more case, they are just going to give you about V1. We need to calculate V2 for this case. What actually we need to do, right? You people need to try. Now actually I'm just going to give it V1. So number V2 கொடுத்தாங்க நீங்க V1 கண்டுபிடிச்சிட்டீங்க. Now V1 actually given. So V1 del 1 is now given. Now we need to calculate V2 and del 2. See V1 is now 1.0, the same value at a degree 0 angle. Just try to find out V2 and del 2. Just calculate பண்ணுங்க V2 del 2. What actually, how actually just solve அதே பண்ணோம் இல்லையா? இப்போ நீங்க என்ன பண்றீங்கன்னா just try to solve V2 and del 2. Make it fast. Small exercise. From this alone only we could able to solve this Gauss seidel. That's why. Just try to find out. In previous problem V2 கொடுத்தாங்க V1 solve பண்ணோம். இப்போ V1 கொடுத்திருக்காங்க, we need to calculate V2 and del 2. Make it fast. Yeah, I am also going to start, no issue. Make it fast, கொஞ்சம் faster solve பண்ணுங்க. The same thing we need to calculate I12. I12 எப்படி இருக்கும்? V1 minus V2, the same formula தான். V1 minus V2 divided by my impedance, right? So it will be somewhat, is that right? So V1 minus V2 divided by 0.1 J. And I12 நமக்கு ஏற்கனவே தெரியும், that is called my, actually they just given V1, right, and del 1. We need to calculate V2 del 2. அப்ப என்ன formula இங்க வரும்? So S complex conjugate divided by S complex conjugate divided by V2, right? So we need to calculate this one. V2 complex conjugate equal to V1 minus V2 divided by 0.1 J. So known value எல்லாம் substitute பண்ணுங்க. Known value எல்லாம் substitute பண்ணா எனக்கு என்னென்ன வரும்? So S ஓட complex conjugate we already know. So 0.6 minus J 0.3 divided by V2 already we don't know, right? So V1 only we know. So V2 we don't know, right? V2 we don't know. Just keep it as same over here. V2 complex conjugate equal to V1 we already know. So right, so 1.0. V2 already we don't know, right? So V2 we don't know, divided by 0.1 J, right? 0.1 J. Right, in our previous equation, we are actually only one variable already we are having about here, right? So only one unknown variable V1, right? After substituting our known values, you could easily rearrange it and you could able to easily calculate V1. But in this problem, we are actually having two unknown variables. You could see this is some of difficulty over here. You could have the two unknown variable V2 complex conjugate and V2. If you are just knowing V2 complex conjugate, definitely you could able to go. But in our given problem, only they just given V1. We don't know about V2, right? So here are two unknown variables are coming. Then how we could able to solve this equation, right? So V2 number solve it will be somewhat difficult, right? So here it will be somewhat difficult. So this is why actually here Gauss seidel method is now it's going to be getting started. Where actually, so right, so with the help of Gauss seidel we could able to solve this equation. This is why actually Gauss seidel method is now employing in power system domain, right? So why actually power system la Gauss seidel method is control. Actually Gauss seidel is nothing but Gauss or mathematician and seidel. So there are two members about 18th century, right? So 18 to 20 around, right? So early 18th century, they just framed one method that is called Gauss seidel method. That is iterative method, right? So it is a iteration method. So before going to solve this entire equation, right? So where actually we need to solve this equation, then only the problem is now getting solved. So before going into that, we're actually just going to use a Gauss seidel method. Once we just understood that Gauss seidel method, then directly we are just going to solve this equation, right? So before into that, we are just going to I am just going to pause it over here, and we'll just going to resume it by about 10 to 15 minutes, right? Once we just understood about Gauss serial. Gauss serial தெரிஞ்சிச்சுனா, and then we just directly moved into next thing, right? So Gauss serial is very simplest mathematical tool, right? We'll see. So before into that solving that our power system equation, we'll have about small uh, example over here, right? So Gauss serial எப்படி work ஆகும்னு தெரியணும் இல்லையா? Then only we could able to easily uh, understood about power system problem, right? So we'll just note it down. So we'll have about two linear equation, 10x minus 3y equal to 4, and 4x plus 5y, I am just randomly using, equal to 7. What is the value for x and y? Just tell me, anyone. What is the value for x and y? We'll have a number of method to solve this equation. You could use a grammar method, by using matrix method, by using a substitution method, or we could use the elimination method. You could able to find out the variable values, right? X and y. Anyone just tell me what is the value for x and y? Anyone just tell me, make it fast. 10x minus 3y equal to 4, 4x plus 5y is equal to 7. What is the value for x and what is the value for y? Anyone just tell me. இதே மெத்தட் நம்ம காஸ் யூஸ் பண்ணி சால்வ் பண்ணலாம், right? What is the value for that one? Anyone just tell me, make it fast. What is the value for x and y? So என்ன பண்ணணும்? You could able to multiply with 4 over here, and we need to multiply with 10 over here. அப்படிங்கிறப்ப x1 y ஓட வேல்யூ கேன்சல் ஆயிருமோ, then finally could able to calculate y. Y கிடைச்சிட்டா again இந்த equation ஏதோ ஒரு equation substitute பண்ணுங்க, x கிடைச்சிரும், right? Or maybe you could use grammar method, that is matrix method. Make it fast. Anyone just tell me the value for x and y? கொஞ்சம் faster solve பண்ணுங்க. கிடைச்சதோ?
Sir, 0.66, 0.87, sir.
0.66 for x, 0.87 for y.
87.
Thank you, Hari. So you just used elimination method, right? So நீங்க இந்த மாதிரி மல்டிப்ளை பண்ணி யூஸ் பண்ணீங்களா? இது 10 ஆலயும் இங்க 4 ஆல மல்டிப்ளை பண்ணீங்களா? அப்படி ஒர்க் பண்ணீங்களா? இல்ல இப்படி வேற என்ன மெத்தட் யூஸ் பண்ணீங்க? Okay, anyway. Anyway, yes, sir, yes, Hari.
நீங்க சொல்ற மாதிரி சார் இந்த
okay, Hari. Okay.
மல்டிப்ளிகேஷன் மாதிரி.
Okay, இது வந்து எலிமினேஷன் மெத்தட். ஓகே, Hari. ஆர் சப்ஸ்டிடியூஷன். ஸோ நீங்க இந்த மெத்தட் யூஸ் பண்ணீங்க, இந்த வேல்யூ கிடைச்சிருக்கு. இதே மெத்தட, ரைட்? ஸோ காஸ் அண்ட் சீரியல் ரெண்டு மேத்தமெட்டிஷியன் they just framed one method, right? ஸோ அவங்க என்ன பண்ணாங்க அப்படின்னா, ஸோ we need to calculate x and y, right? ஸோ இந்த மெத்தட் அண்டர்ஸ்டாண்ட் பண்ணிட்டு then just directly jump out our equation, right? No issue, right? ஸோ அவங்க என்ன பண்ணாங்கன்னா, x and y ஓட வேல்யூ கண்டுபிடிக்கணும் இல்லையா? தட்ஸ் வை they just framed the equations, right? ஸோ இதுல இருந்து x மட்டும் எடுத்துட்டாங்க. ஸோ ஃபர்ஸ்ட் ஈக்குவேஷன் வந்துட்டு இந்த 10 plus 3y வந்துட்டு x மட்டும் கண்டுபிடிக்கிறாங்க. தட் இஸ் கால்ட் 10x எங்கேயே வச்சுக்கிறாங்க, right? So now 4 remaining things, just bring it to my right side. 4 plus 3y. Now this just having x alone only over here. Up now 4 plus 3y whole divided by 10. This is the value for x. Equation number 1. Simply எடுத்துட்டாங்க. The same way second equation the y மட்டும் calculate பண்றாங்க. அப்ப எனக்கு என்ன வரும்? So y equal to 7 minus 4x. Right? 7 minus 4x is now coming my right side. 7 minus 4x whole divided by, the 5 is now in the form of divide. So whole divided by 5. This is equation number 2. So this is a procedure actually Gauss and serial they just using, right? So இதே solution தான் வரப்போகுது, but how actually is now they are just getting, right? So x ஓட value 4 plus 3y divided by 10, 7 minus 4x by 5. I'm just going to use one more thing, right? So now initially they're just assuming x value, y value is now 1.0. Initially they're just guessing. Initially they're just guessing 1.0, 1.0. Initially they're just assuming x and y value, right? So in the value என்ன பண்றாங்க, initially இந்த x ஓட value, x ஓட equation y ஓட equationல substitute பண்றாங்க, right? So இப்போ என்ன பண்ண போறோம்னா, இந்த y க்கு பதிலா நான் இப்போ initially guess பண்ணேன் இல்லையா, இந்த value இதை நான் substitute பண்ண போறேன். That is called my iteration number 1. Iteration number 1ல என்ன பண்றாங்கன்னா, right? This is what iteration method. Step by step போயிட்டே இருப்பாங்க. So until convergence ஆறவளோ the same answer is getting வரவரலோ சேம் ஒரே வேல்யூ வரும் இல்லையா ரிப்பீட் ஆகும் இல்லையா that's what a solution. அதாவது 0.66 வரவரலோ they will just go in continuous converge ஆறவரலோ they will just go. இப்போ இனிஷியலா கெஸ் பண்றாங்க 1010 வச்சுட்டாங்க ரைட் 111. நான் இனிஷியலா இந்த ஈக்குவேஷன் சப்ஸ்டிட் பண்றேன். வாட் இஸ் வேல்யூ ஃபார் y that is 1 1 சப்ஸ்டிட் பண்ண என்ன வரும் 4 plus 3 that is x equal to so 4 plus 3 into y1 that is the y value 1 so 3 into 1 whole divided by I guess 10 right so divided by 10. So what is the value for x now 4 plus 3 7 by 10 that is around 0.7 right so x value now 0.7. இந்த 0.7 immediate என்ன பண்ணுவாங்கன்னா இந்த ஈக்குவேஷன்ல சப்ஸ்டிட் பண்ணுவாங்க செகண்ட் இந்த x க்கு பதிலா இப்ப கிடைச்ச வேல்யூ 0.7 இது சப்ஸ்டிட் பண்ணுவாங்க. அப்ப what is the y value so y ஓட வேல்யூ equal to what is the equation now 7 minus 4x 7 minus 4 into x ஓட வேல்யூ 0.7 now 0.7 whole divided by 5. now calculate பண்ணுங்க ஒரு வேல்யூ வரும் right so 4 7 are 28 2.8 so 7 minus 2.8 divided by 5 ஒரு வேல்யூ வரும் இல்லையா that is what a y right so this somewhat some values வரும். see இந்த வேல்யூ தான் எனக்கு ஐட்ரேஷன்ல கிடைச்ச ஃபர்ஸ்ட் வேல்யூஸ் ஃபர்ஸ்ட் செட் ஆஃப் வேல்யூஸ். so iteration number 2 ல என்ன பண்ணுவாங்கன்னா instead of taking this initial value they are actually just going to use these values. iteration number 2 ல instead of x12 எடுத்ததுக்கு பதிலா என்ன பண்ணுவாங்க இப்ப கரண்டா கிடைச்ச வேல்யூ மறுபடியும் யூஸ் பண்ணுவாங்க iteration number 2 ல யூஸ் பண்ணுவாங்க. so iteration number 2 ல என்ன எடுத்துப்பாங்க so x ஓட வேல்யூ 0.7 now y ஓட வேல்யூ ஒரு வேல்யூ வந்திருக்கும் நான் இங்க கால்குலேட் பண்ணுங்க இந்த வேல்யூ மறுபடியும் இந்த ஈக்குவேஷன்ல சப்ஸ்டிட் பண்ணுவாங்க until they will just go right so until they will just go repeatedா பண்ணிட்டே இருப்பாங்க finally x ஓட வேல்யூ நீங்க ஹரி சொன்ன மாதிரி 0.66 னு ரிப்பீட்டடா ஒரு ஆன்சர் வந்துட்டே இருக்கும் அங்க வந்து ஸ்டாப் பண்ணிடுவாங்க right so this is what a procedure about my Gauss seidel method. so இது வந்துட்டு நம்ம ரிப்பீட்டட் ப்ராசஸ் தான் ஸோ ஒரு சாஃப்ட்வேர் வச்சு பண்ண முடியும் தட்ஸ் கால்ட் நம்ம மேட்லாப் வச்சு பண்ண முடியும் வில் சி எப்படி ஒரு கால மேட்லாப்ல பார்த்துக்கலாம் சி clear all. so before into that I'm just going to use a library over here. So people need to write entire problem right so step 1 step 2 step 3 just go with it. I'm just going to use it Gauss seidel introduction Gauss seidel introduction right so introduction to formula நீங்க ஸ்டெப் பை ஸ்டெப் நார்மலா யூஸ் பண்ணிக்கோங்க ஸ்டெப் 1 ஸ்டெப் 2 எல்லாமே நீங்க யூஸ் பண்ணிக்கோங்க I'm not going to go with it because I'm not having much time over here right and directly I'm just going to jumping into coding part right code step 1 CLC and clear all and now actually I'm just going to start my entire equation right so equation another we need to solve this equation right so equation x equal to right so x equal to what is the equation so 4 plus 3y right 4 plus 3y equation 4 plus 3y 3y so 4 plus 3 star y whole divided by 10 whole divided by 10. This is what equation number 1 and y equal to 7 minus 4x 7 minus 4x and whole divided by 5. These are the two equations right so these are the two equations we need to solve it right so initially guess பண்றாங்க இல்லையா initial guess என்ன பண்ணிருக்கோம் initial guess right so initial guess it will be 1 1 we need to initial guess I'm just going to use it command symbol initial guess நீங்க எதனால வச்சுக்கலாம் initial guess you could have its own value initial guess value you could choose your own value right நீங்க will check it out right so check பண்ணிக்கலாம் x ஓட value 1 and y ஓட value 1 you could choose your own value no issues right and until we need to converge எனக்கு solution கிடைக்கிற வரையில we need to go right so அப்பனா we need to take a repeated process right so iteration 1 iteration 2 iteration 3 right so repeated process நம்ம என்ன loop யூஸ் பண்ணலாம் for loop யூஸ் பண்ணிக்கலாம் right for loop I'm just going to execute about 5 times right 5 times I'm just going to execute it. So 1 is to 5. About 5 times the loop is going to be executed, right? 5 times the loop is going to be getting executed. Right, so in the body of the for loop enna statement irukko the 5 times it's going to be getting executed. That's why I am going to copy just to paste it, enter into the body of that for loop, right? So in the for loop in the statement 5 times is going to be getting executed, right? We'll see. So initial value x order value 1, y order value 1. So penavavu, so x order value 1 is now going to be substituted over here, right? So and y order value is now going to be getting substituted over here. And 5 times this value is going to be getting evaluated over here. Just will once again we'll just run it. I think Hari, am I right? Initial first step, got idea, answer kadachudha paranga. X order value 1, y order value 1. Initial நம்ம கொடுத்த guess பண்ண value, initial value. So அப்ப substitute பண்ண என்ன வரும்? 4 plus 3 into y1. So 7.7, right? Got a value 0.7 கிடைச்சிருச்சா? இந்த 0.7 immediate இங்க வந்துட்டு apply ஆகும். 0.7 into 4, 2.8, 7 minus 2.8, that is 4.6 or 3.6 divided by 5. It will be coming 3.6 பண்ணீங்கன்னா 0.84 கிடைக்கும். This is what my first iteration value. So 1 கொடுத்தா இந்த value கிடைச்சிருக்கு. அடுத்து என்ன ஆகும்? iteration number start ஆகும், right? Iteration number 1 is now coming. So அப்ப எனக்கு என்ன ஆகும்? உடனே இந்த x ஓட value substitute ஆகுது, y ஓட value changes ஆகுது. Again y ஓட value is totally 5 times is now going to be executing. அப்ப நான் எனக்கு display பண்ண போறேன் what is the value, right? என்னென்ன values வந்துச்சுன்னு பார்க்கறதுக்காக display பண்ண போறேன் in the form of array. What are the values I need to get it? எனக்கு x ஓட value வேணும், எனக்கு iteration ஓட value வேணும். So எனக்கு iteration ஓட values வேணும், as well as x ஓட value வேணும், y ஓட value வேணும். I'm asking about array ல display பண்ண சொல்றேன். 1 second will be just going to run it. Display, actually I missed it, display, right? Display மூணு value கொடுக்கிறோம், that is I, x and y, right? So we need to use the open parenthesis, close parenthesis. I'm just going to display 3 variables x, I, y. Just one second, just run it. About iteration number 1, எனக்கு value என்னென்ன கிடைச்சிருக்கு? 0.7, 0.84. iteration number 2.0, that is iteration number 2, எனக்கு value பார்த்தீங்கன்னா 0.6587. இதெல்லாம் வாட்ச் பண்ணிட்டே வாங்க. When it will converge, right? So repeated answer வரப்ப it will going to be stop it about 5 times பார்க்கலாம். And iteration number 3, x ஓட value 0.66, y ஓட value 0.89. And iteration number 4, 0.66088714. நல்லா வாட்ச் பண்ணி பாருங்க, previous value repeated ஆகுது பாருங்க, repeated ஆகல. Now iteration number 5, 0.66 previously இப்போ 0.14, 0.87. Still now it's not converging. அப்ப என்ன பண்ணலாம்? iteration count கொஞ்சம் increase பண்ணலாம். for loop iteration count increase பண்ணா you'll see 10 times நான் evaluate பண்றேன். Now you could see iteration number 5 பாருங்க, iteration number 5, x ஓட value 0.6614, 8709. அடுத்த வேல்யூ பாருங்க, iteration number 6, 0.6613, 0.8710. iteration number 7, 7th iteration onwards, 6th iteration ஓட வேல்யூ பாருங்க, 7th iteration வேல்யூ பாருங்க, the same value is now occurring. It shows that value is now converging. This is what a final solution for x and y. Am I right, Hari? Your solution நீங்க என்ன சொன்னீங்க? x ஓட வேல்யூ point that is called எவ்வளவு சொன்னீங்க? 0.66, 0.866, 0.87. நம்ம மேட்லாப்ல பார்த்த வேல்யூ கரெக்டா இருக்கா? ரைட். iteration number 6ல பாருங்க answer, and iteration number 7ல your 0.66, 0.87, right? Got a value. This is the Gauss Seidel method, right? So in the method then they just propose பண்ணாங்க at around 18th century, right? So this will help you about to calculate your variable x and y. You could able to calculate your variable values, right? So two linear equations solve பண்ணி answer கண்டுபிடிக்க முடியும் with the help of iterative method, right? So you'll have better solution as well as, right? So நீங்க manual solve பண்றத விட ஒரு software or computer solve பண்ற machine solve பண்றப்ப it will be somewhat very easiest one, as well as accurate ஆவும் கிடைக்கும். Time consumption நமக்கு அதிகமாகும். But 18th century power system அந்த அளவுக்கு நம்ம evolve ஆகல. But if nowadays entire power system network, they're just analyzing with the help of this software things, right? Now anyway, the same application, right? So the same technique, Gauss-Seidel technique, we are actually just going to implement on my power system problem, right? So what is the equation number? We'll just going to try with that the same equations, the same problem in our with the help of this technique. We are just going to solve power system problem, right? We're just going to try with that simple power system solution, power system network. We are just going to use a text, right? Not coding. Power system analysis, power system simple network, power system simple network, right? Actually, we are having about image over here. You could able to import image also. No, I guess image is not there. I guess we couldn't able to import image. I guess. Anyway, we'll try. Where actually that our simple network, actually we have drawn this simple network over here, right? This sort of simple network. We could able to select it. We couldn't able to select, and this was a simple image, right? And we are actually going to use this one over here, right? So actually final equation namukku enna kadachadu, we are actually end with one equation, right? So v1 v2, this is what equation, right? uh, by using Gauss-Seidel, right, we could able to calculate the value over here, right? So எனக்கு ஃபைனலா சொல்லுங்க, இதை கிராஸ் மல்டிபிள் பண்ண பிறகு எனக்கு என்ன கிடைச்சிருக்கு? We need to calculate v2. So அப்ப v2 என்ன கிடைச்சிருக்கும்? v2 equal to 0.1j multiplied by this entire equation and this one, right? Anyone just tell me this entire equation values? கொஞ்சம் ஃபாஸ்டா சொல்லுங்க. 1 second, I'm just going to rewrite it over here, right? Anyone just tell me, make it fast because I'm not having enough space. So 0.6 minus 0.3. 0.6 minus 0.3 j divided by v2 complex conjugate. இந்த பக்கம் இருந்துச்சு. In my right side என்ன இருக்கு? 1.0 minus v2. 1.0 minus
angle 0
v2 angle விட்டுருங்க, angle 0 degree அதை விட்டுறலாம் வேண்டாம், right? And j 0.1. இதுல இருந்து எனக்கு v2 மட்டும் சொல்லுங்க. v2, that is v2 equal to, அதை மட்டும் சொல்லுங்க என்ன வரும்? இது இங்க மல்டிப்ளை பண்ண போறோம் and இது இங்க மல்டிப்ளை பண்ண போறோம், right? We need only v2. j.1 into 0.6 minus 0.3 j whole divided by v2. v2 அப்படியே வச்சுக்கலாம், right? So v2 அப்படியே வச்சுக்கலாம். v2 complex conjugate, and in my here right side it will be v2. அப்ப இந்த 1 இந்த பக்கம் வந்துச்சுன்னா -1 இல்ல +1? -1, I guess, right? Am I right? Or 1 minus this one plus this one totally minus. Am I correct? Yeah, right? 1 minus total j this one, right? This is what a final equation. Am I correct? Check பண்ணிக்கோங்க.
Yes sir.
இந்த equation correct? So final equation என்ன இருக்கும்? 1 whole minus in the total terms வருமா? அப்படியே வருமா? Am I correct, right? Yeah, am I right? Check பண்ணிக்கோங்க. Because this equation அப்படியே நம்ம வந்துட்டு Gauss-Seidel யூஸ் பண்ண போறோம், அதுக்காக நான் கேக்குறேன். equation கரெக்ட்டா தான் ஆன்சர் கரெக்ட்டா வரும், that's why. Am I right? This equation is right? Check பண்ணிக்கோங்க ஹரி. என்ன ரீசன்னா இந்த v2 இங்கேயே வச்சோம்னா மைனஸ் இந்த பக்கம் வரும், அப்ப இந்த டோட்டல் இது மைனஸ் ஆயிடும், இந்த டேர்ம் டோட்டல் மைனஸ் ஆயிடும். அண்ட் இது 1 இருக்குல்ல, இந்த 1 இந்த பக்கம் வந்திருக்கு, பிளஸ் -1 வரும், இந்த 1 மைனஸ் இந்த பக்கம் வரும், ரைட்? டோட்டல் -1. அப்ப இந்த மைனஸ் இந்த பக்கம் போனதுன்னா +1 ஆயிடும், மற்ற டேர்ம்ல மைனஸ் ஆயிடும், ரைட்? ஓகே. Now we are actually just going to use this equation. So v2 equal to 1 minus, அந்த equation அப்படியே சொல்லுங்க. v2 equal to 1 minus, இது உள்ள மல்டிபிள் பண்ணி சொல்லிடுறீங்களா? உள்ள மல்டிபிள் பண்ண என்ன வரும்? 0.06j. உள்ள மல்டிபிள் பண்ண என்ன வரும்?
plus 0.06j minus
0.06j மைனஸ் முடி உள்ள வரும், j ஸ்கொயர் வரும், ஜே ஸ்கொயர்னா -1 ஆல்ரெடி ஒரு 0.3 இருக்கு. அப்போ பிளஸ் 0.03 கரெக்டா 0.03 டோட்டலா மைனஸ் வெளியில இருக்கு. ஹோல் டிவைடட் பை V2 கான்ஜுகேட் இருக்கு. கரெக்ட்டுங்களா? am I right? 0.06 J டோட்டலா வெளியில ஒரு மைனஸ்ல இருக்கு. ஸோ அப்படின்னா 1 மைனஸ் பிராக்கெட்ல 0.06 ஜேக்கு பதில் என்ன பண்ணணும்? 1i. ஜேக்கு பதில் 1i we need to use it. 0.06 J and plus 0.03 செக் பண்ணிக்கோங்க. 0.03 whole divided by V2 complex conjugate. So whole divided by conjugate என்ன ஃபங்க்ஷன் அப்படின்னா என்னோட மேட்லாப்ல CONJ, that is why conjugate, complex conjugate. just நீங்க டைப் பண்ணவே இந்த ஃபங்க்ஷன் உங்களுக்கு ஹைலைட் ஆகும், கீழே காமிக்கும். CONJ, it will denotes that complex conjugate of V2. So bracketல V2, right? This is what entire equation. So equation கிடைச்சிருச்சா? And plus 1 already we have used it over here, right? Plus 1 முன்னாடியே கொடுத்துட்டேன். So V2 equal to 1 minus 0.06 J plus 0.03 divided by conjugate of V2. This is what entire equation. இதை வந்து நான் வந்துட்டு ஃபார் லூப்ல எக்ஸிக்யூட் பண்ணுவேன் ஒரு 5 times or 10 times. எனக்கு ஆன்சர் கிடைக்கிறவர்களும் இந்த மாதிரி எனக்கு கன்வர்ஜென்ஸ் ஆகிறவர்களும் நான் என்ன பண்ண போறேன், ரிப்பீட்டடா சேம் ஆன்சர் வரவரை நான் ரன் பண்ண போறேன். ரைட்? ஃபார் தட் பர்பஸ் we need a for loop. அதுக்கு முன்னாடி காஸ் சீரியலோட என்ன ப்ரொசீஜர்? we need to use a initial guess, right? So we need initial guess. Now CLC clear all initial guess. So here actually we are having about variable v2. அங்க வந்துட்டு நம்ம ப்ராப்ளத்துல x1 xy னு வேரியபிள் வச்சிருந்தோம். இங்க actually that variable is now v2. That's why v2 equal to initially I'm just going to use it 1. ரைட்? நீங்க வாட்ச் பண்ணி பாருங்களேன், ஆன்சர் 1 தான் எடுக்கணுமா, எனக்கு வேற வேல்யூஸ் எடுக்க கூடாதா? ஐ குட் யூஸ் 5. ரைட்? இனிஷியல் கெஸ் நீங்க என்னனாலும் படிக்கலாம், எந்த வேல்யூனாலும் இனிஷியல் கெஸ் எடுத்துக்கலாம். ரைட்? ஐ அம் ஜஸ்ட் யூஸ் இட் 20. இனிஷியல் கெஸ் நீங்க எந்த வேல்யூ எடுத்தாலும் எனக்கு ஆன்சர் வந்துட்டு 0.66 0.87 தான் வரும். பட் எனவே நீங்க எடுக்கிற இனிஷியல் கெஸ் வச்சு என்ன ஆகும்னா என்னுடைய ஐட்ரேஷன் கவுண்ட் சேஞ்ச் ஆகும். ஆன்சர் கிடைக்கிறதுக்கான கால்குலேஷனோட ஐட்ரேஷன் கவுண்ட் சேஞ்ச் ஆகும். பட் ஆன்சர் ஏதோ ஒரு செக் இட் அவுட். நான் இப்போ இனிஷியல் கெஸ் சேஞ்ச் பண்ணிட்டேன், 25 கொடுத்துட்டேன் இன்ஸ்டெட் ஆஃப் 111. ஜஸ்ட் 1 செகண்ட் ரன் பண்ணி பாருங்க, இந்த சேம் வேல்யூ தான் வரும். ரைட்? சேம் வேல்யூ தான் வரும். பட் எனக்கு ஐட்ரேஷன் கவுண்ட் சேஞ்ச் ஆகும். ரைட்? ஐட்ரேஷன் கவுண்ட்ல எனக்கு ஆன்சர் கிடைக்கிற ஏரியா சேஞ்சஸ் ஆகும். அவ்வளவுதான். தட் இஸ், நீங்க பிளஸ் தான் கொடுக்கணுமா? அதெல்லாம் கிடையாது, மைனஸ் கூட கொடுக்கணும். -5 I'm just giving the same value it will be giving, but the iteration count தான் உங்களுக்கு வந்துட்டு ஆன்சர் கிடைக்கிற கவுண்ட் வந்து சேஞ்சஸ் ஆகலாம். ரைட்? நத்திங் ராங் இன் தட். ஸோ இட்ஸ் வாட் மை காஸ் சீரியல் ப்ரொசீஜர். த சேம் வே நாங்கள் என்ன பண்றோம்னா வீட்டோட இனிஷியல் கேஸ் வந்துட்டு 1 கொடுப்பேன். ஃபார் லுக் அபவுட் ஒரு 5 times or 10 times ரன் பண்ண போறேன். இனிஷியலி ஐம் கோயிங் டு அபவுட் 5 times or 10 times ரன் பண்ணிக்கலாம். So now enough 5 times ரன் பண்றேன். ரைட்? ஃபார் லுக் 5 times ரன் பண்றேன் and finally I'm just going to end it. end பண்ணிட்டேன். ரைட்? So for loop is now going to be getting ended and I'm just going to display the same thing. Right? So I'm just going to display the same thing. So I'm just displaying about iteration count and v2 நான் டிஸ்பிளே பண்ண போறேன், but should be in the form of angle of v2. right? So absolute value of s, right? So absolute value of, that is called absolute value of v2 space angle னு கால்குலேட் பண்ண போறோம். angle of v2. so angle of v2, but it should be in the form of radian ல வரும். நான் டிகிரிக்கு மாத்த போறேன். 180 divided by 3.14. right? So I'm just going to calculate in the form of degree. So angle calculate பண்ணியாச்சு, value calculate பண்ணியாச்சு. right? Initial guess value 1 நான் assume பண்ணிருக்கேன். So 5 times execute பண்ண போறேன் இந்த equation. right? We'll see what is the value for v2. right? I'm just going to execute 1 second. now got a value. எனக்கு 5 times நான் ரன் பண்றேன். எனக்கு பாருங்க ஐட்ரேஷனோட வேல்யூ ஃபர்ஸ்ட் 1 ஓட வேல்யூ கால்குலேட் பண்ணிருக்கேன் 97 minus 3.5 டிகிரி. எனக்கு ரிப்பீட்டடா ஆன்சர் வரப்ப நான் கன்வர்ஜென்ஸ் ஆகுதான்னு செக் பண்ணிட்டே வரணும். எனக்கு கன்வர்ஜென்ஸ் ஆகல பாருங்க. செகண்ட் ஐட்ரேஷன்ல 9672 போகுது. ரைட்? பட் டிகிரி எனக்கு கன்வர்ஜென்ஸ் ஆயிடுச்சு. பட் ஆனா அடுத்த ஐட்ரேஷன்ல ரெடியூஸ் ஆகுது. 9671 3.55 9671 3.55. now it be changing. right? so change ஆகுதா? iteration 5 9671 3.55 90. anyway நான் iteration count increase பண்றேன் 10. so 10 increase பண்ணா எனக்கு convergence ஆயிடும். right? finally it's now convergence ஆயிடுச்சு பாருங்க. iteration number எங்க கன்வர்ஜென்ஸ் ஆயிருக்கு, it will be around iteration number 5ல கன்வர்ஜென்ஸ் ஆயிடுச்சு, ரைட்? ஸோ இதுக்கு பாருங்க 9671 3.55, 9671 3.55. ஸோ இதுக்கப்புறம் பாருங்க 9671, the same value is now occurring. It shows that value is now convergence ஆயிடுச்சு, ரைட்? ஸோ about iteration number 6ல. So this value for V2. V2 the value 0.96 at minus 3.5 degree, right? So this is how actually Gauss seidel is now working to solve my this network, right? So power system analysis la Gauss seidel how actually it's now working, right? So I think I'm just going to pause it over here and we'll continue by tomorrow classes, right? So we'll see one more power system simple network. Once we just finished that simple network and we directly jumped into this entire formula which is given in our manual, right? So now direct in the coding solve it will be difficult. With the help of some example we are just now moving. In the example நீங்க பாத்தீங்கன்னா ஈஸியா புரிஞ்சிடும். இது சேம் ப்ராப்ளம் we are actually just going to see by tomorrow, right? So இதுக்கான கோடிங் நம்ம எழுத போறோம், right? So it will be very easiest one. So no need to get panic, right? It will be very easiest one. Simply for loop தான் எல்லா யூஸ் பண்ண போறோம். நம்ம இங்க யூஸ் பண்றோம் இல்லையா, the same for loop தான் இங்க யூஸ் பண்ண போறோம், right? So the same for loop. So once just we finish this coding part, directly we are just parallelly we are just going to work with that Simulink area. So இங்க வர வேல்யூ Simulink ல பாத்துக்கலாம், right? Simulation ல நம்ம கிராஃபிக்ல பார்க்கலாம், right? So until we'll just have this work out பண்ணி பாருங்க, the same problem, right? So I'm just going to give you about 5 more minutes to you. See இந்த coding அப்படியே நீங்க சேவ் பண்ணி வச்சுக்கோங்க in our Matlab. It will be useful for you, right? Just save பண்ணிக்கோங்க. I'm just going to pass it over here. ஹரி செக் பண்ணி பாருங்க, இதே கோடிங் செக் பண்ணி Matlab லாக் பண்ணி வச்சுக்கோங்க. சிம்பிள் பவர் சிஸ்டம் நெட்வொர்க் யூசிங் லோட் ஃப்ளோ அனாலிசிஸ் யூசிங் சிம்பிள் காஸ் சீடல் மெத்தட் சால்வ் பண்ணி டைட்டில் மட்டும் மாத்திக்கோங்க, சிம்பிள் நெட்வொர்க். நம்ம மேனுவல் இருக்கிறது யூஸ் பண்ண போறோம் லேட்டர். டைரக்டா அங்க போனா கொஞ்சம் கஷ்டமா இருக்கு இல்லையா, தட்ஸ் வை. ஸோ ஈக்குவேஷன் நீங்கள் டைப் பண்ணுறப்ப இந்த ஓப்பன் ப்ராக்கெட், க்ளோஸ் ப்ராக்கெட், மல்டிப்ளிகேஷன் அண்ட் ஜேக்கு பல 1i அதை மறந்துடாதீங்க. அண்ட் we need this parenthesis. இதெல்லாம் somewhat very difficult, sorry, somewhat very important, right, to while having this one. I think we reached 12 o'clock, right? And tomorrow we'll see about one more power system network and we'll finish it up by tomorrow and we'll just going to finish up the entire third experiment, right? So thank you all for listening and we'll meet you by tomorrow, right? Thank you all once again.
Thank you.
Thank you very easy இருந்ததா?
Thank you, sir.